Hello everybody, welcome to another stream. How are we all doing? Yeah, so last stream we was working on improving the image-based lighting. So yeah, currently we've got this cube map here which in the background obviously. And we have this reflection in here. So what you notice now, we added this last stream, is you can increase the roughness, and what you'll get is this sort of blurrier version of the reflection. We did this by downsampling the cube map. That's given us some, not that one, that's the radiance one. Yeah, so we got this 2K cube map, but we've got different MIP levels. So we're basically sampling from a downsampled version, based on how rough it is. So the rougher it is, the more downsampled it is, so the blurrier it's going to be. But the issue with this approach is that it just gets a bit boxy looking. And it gets a bit... Yeah, the blur is not... It can be improved basically, I think. So we want to try a different approach. And that's what we're working on today. We started working on it last stream. We're following the Learn OpenGL Diffuser Radiance chapter. So we're nearly finished with it. We've got the shader implemented. We've just only got it working for one face. So we generate this thing called an irradiance map. And irradiance is radiance that comes from all directions. So you've got... So I had some debugging stuff last time. But effectively you have like a surface. Well, effectively we have another cube map. And each pixel is as if we take a normal and then get a hemisphere or whatever and fire all rays over the hemisphere and sample the environment map and then take the average of all of those samples, and then that's what that pixel will get. So whenever we next point to that pixel from the shader, we can just basically cache what it was like to, you know, shoot rays all over the hemisphere at that angle. So it's obviously an estimation since it's a cube map. It only gets stuff that's infinitely far away. But it's good to get the PBR code correct. And this is a good way to test it all out. So we just, we've done this basically. We just got to finish it off. So I think we know it does work. It only does it in one direction at the moment. So, and it takes some time to actually to run. So I think what I want to do is play around with performance for a minute and just see like why is it taking so long, and see like what things I can tweak. So I'm just going to turn on this. We're going to profile individual shaders. So I don't understand how individual sphere lighting will create appropriate lighting for objects composed of these spheres. Still don't understand how individual sphere lighting will create appropriate lighting for objects composed of these spheres. I'm not sure what you mean, ultra sentinism. What do you mean by that? So we'll get improved lighting, or like I'm not sure you mean. Hey Glorissa, how's it going? Oh, hey there, Chando, how's it going? Yeah, it's been good. I've just been working today. I quickly went and mowed the lawn because I got someone coming over to look at the garden because it's kind of been ruined since we got the house. So hopefully they come and fix it. I've got to educate myself on what I want, what I can demand. So that's my tomorrow before they come on Thursday. For the first time you wrote system level software, awesome. What is what is it? What is it like? What program? Uh, Going good. Just came back from uni. Too much uni. Not long left. Are you in your final year now, or have you got another year after this one? Will your future game have characters, environments, everything, all made of little spheres? Yes, that's the plan. Well, actually, there'll be a slight tweak to that plan, which I haven't announced yet. Which we'll get into after we've done PBR. I'm going to redo the renderer. With an old renderer, but redone. So I want to get the time it takes to do this. Should I run every frame? Irradiance, render irradiance map. Let's just run every frame, but maybe it's bad. Yeah, then we can just stop it when it... Okay, to render an irradiance map. Okay. Takes 8 milliseconds, 3 milliseconds. Right. I was seeing hundreds of milliseconds before, so I was concerned. But I guess that's because I had it as a super big resolution. But yeah, you only meant to... Yeah, this is still not good. But... Yeah. Okay. But it doesn't matter because this is just purely used for demo code anyway. This shader. I'm taking master courses now. One more year. Oh, okay. Nearly there then. So how long have you been doing it for? Have you been doing it? Is it a 3-year course? Okay, so the way that this shader is working is we've got a pixel in the cube map. From the center cube map, we have a normal to there. We blast a bunch of rays out across the hemisphere, sampling the cube map, a different cube map, which is the environment map. This is the diffuse irradiance map. Then we average this all into a single pixel, put it in there, and the next time we access it, we've just cached this, basically. So things will look a bit murky, and that's okay, I think. Well, I think we need to put it in upside down. Irradiance map, dim, take 1. If we put it in upside down, then it'll look right. There you go. So yeah, so the thing is about this, right? We can test, let's for now only fire a ray out the normal. We did yeah, let's only fire a ray out the normal. and then store that. Reason being is because I want to quickly test to see if it is correct. Last stream we did set up all the debug drawing and we saw the hemisphere and the normal, but I just want to check it's correct inside the texture basically. There we go, we've seen a downscaled version. So that should be, if we compare it to another one, environment map, layer, was that layer 4? Oh, it's just up there. It must be layer 4 then. Where's the trees coming from though? Oh, I need to zoom out. Yeah, zoom out. So yeah, that's looking alright. So the issue is we've got to get the so that's fine. So what we can do is we can do this to debug. So I might just say if 0 debug seeing a low res version of the sample cube map. There we go. So that's good. So I'll enable that for now. So what we want to focus on is getting all of the irradiance map have the correct layers, because right now they're all the same. They're all the same direction. So we need to get all the different directions correctly in. So we're going to rotate the normal. No, apparently it's in Japan. I got them from here. Yokohama, Japan. Park somewhere. Apparently planet Earth looks the same. Hey Swing Funk, how's it going? How you been? It's been a while. I mean, if the spheres are on a grid, and spheres are not intersecting in ways have quasi surfaces, lighting them, or macro will end up being effed up. Even without grids will be difficult. That is my concern. I'm not experienced as you though, so it might be managed something erroneously. Fair play. Well, yeah, this is the whole point with doing this research and development, is to see can we make something look good. So this is the reason why we're doing this research and development. I don't see many rendering art styles doing stuff this way, so this is just the reason why we're doing it. We're not slight spoilers. We probably won't be using grids anymore, and we might not be using spheres per se. Still spherical kind of shaped. That is coming after PBR. So I think after PBR we're going to have a bit of a play with, well, we're going to do a BVH traversal renderer again. Better be better than the last one. We've got so many more things since the last BVH renderer that we did. We're like debug drawing. We're going to refactor the code base, like clean up basically restart the graphics file. Just copy, paste it, delete everything out, and probably refactor the code base so the engine stuff is in a separate place, and then start working on having the ability to make models and stuff within the game. And from there we can play around with lighting and such and just see what we can make look good. I think I did actually go to that park. I think it's exactly here. That's a coincidence. Fair play. Um, Let me do this. Well, I don't want to open up Google Maps because I don't want to get doxxed, but fair play. I'll um I'll believe you. Um so yeah, how are we going to point in the right direction? So we're basically rendering one face of a cube map at a time. Um oh, sorry, of the irradiance map from by sampling the cube map. So we need a way we write into the irradiance map perfectly fine with layers manually. But what's a way? What is a way where we could do it? See, I wonder if I should just not sample it as a cube map, take it in as a 2D array texture, and just manually do the cube map sampling. Um, yeah, that might be okay. I think we can manually do the cube map sampling. And that way, because the other way you got to do it is you pass in a quaternion or something, and you rotate, or you do some if statements and you swizzle the normal. But I think we could just manually do. No, but then it's gonna. Yeah. Um. How does sample cube map work? Something like that. I remember seeing some code before where there was just some if statements basically, and they look quite simple. Cube map sample. It's probably quite. If I think about it, it's probably relatively simple. Right, internally. There you go. Sample of key maps implemented this way. Intrinsic users on consoles, right? So, given your normal or your vector, right. As you can see, normalization is implicit. See last line. Right. So I guess it does some form of scaling. Reasons why you want to sample key map manually in this manner, in particular use case of shadow aliases, putting all your shadows in a single texture. So applying shadows in the scene can be done in a single pass. Fair play. But yeah, I think we can maybe do it manually and get the UV manually. It seems quite simple. And this way we don't have to do any rotation. Is that right? No, I think we're better off doing the rotate, just rotating it the normal. Yeah, no, this is a dumb idea because you're not always going to be sampling from a single face. I was thinking it would only be sampling from a single face, but even if you're filling in this pixel, these rays are firing off to different faces. So the sample cube map face won't be the same as the face that we're writing in for the irradiance map. So that is a bad idea. So the next good idea would be just rotate. So we've got quaternions. I guess we could use those. So yeah, we need to be able to So I think we can just say basically quaternion don't have any quaternions anywhere? No, I definitely put a quaternion in. Why don't I see one? Here we go. Right, quaternion. I want to rotate on mol. Yeah, mol v quaternion. Right. So I want some form of rotation and normal. Produce me normal, please. So I think that, yeah, that'll stay normalized. So we simply just need to pass that in. I think it's capital Q. So when we fire the shader off, for each of the layers, we've got to produce. I did do a thing called normal. Yeah, these be quaternions now. How do you initialize one of these boys? Past me. How did I do it? Look at up. This should do it. Axis and like an angle. Which one do I want to do? Probably look at. So, say if you get the normals, then look at would just be. Oh, you need a forward and up, eh? Right, I guess we could. So you're going to be looking forward by default. So we just need to say how do you rotate to get to. So what axis do we rotate from forward to get to? Okay, that's fine. Axis, axes, and then angles, I guess. We can fill those in quite easy. So normals needs to be replaced with axes. So in terms of like this first one, I think needs to be right, left, right, left, up, down, forward, back. So to get to the right from forward along the y-axis, using the y-axis as the rotation. Using the y-axis as the rotation, we need to get. Well, you could I could probably code this as a. Yeah, using the y-axis as a rotation, how much do I need to go by? Degrees. Oh, my days. Is that a function or something? It's been a while since I used this one. Intrinsics. No, it's in the maths, isn't it? Scalar. Yeah, degrees and radians. So, radians F32. Right, so then you want 90 degrees. So you rotate along the y-axis 90 degrees to move it to the right-hand side. Oh yeah. So the left is negative 90. To go facing forward, you do absolutely nothing. So you want the identity. I don't know how that's going to work, but hopefully that does it. Then when you're on the back, you want the mirrored version. So you probably want... How would you do that? That's interesting. How would you get that? Yeah, we should put a breakpoint in and analyze what we get. I don't think that will do it. And then if you want to get... Oh wait, these are Z's. They're Y's, sorry. Yeah, so for the Z, sorry, for the Y, you point it forward. You want to go up. You need to use the x-axis. And one of them is 90 degrees, the other one is negative 90 degrees. I guess it's positive to go up and negative to go down. Right, so this is interesting. I think I would like to probably print these out, to be fair. Yeah, something like that. And then, so BC rotation dot X, Y, Z, W, and then we can just put an exit in here, because I would just like to see, oh, for crying out loud, what happened here? Why have we got a SPIV error? What craziness is happening here? A block or buffer block cannot be nested within another block or buffer block. It's a strut, isn't it? You're saying I can't have a strut in there? In my push constants? Yeah, that compiled. Run it loud. Spivvy. I know why it's doing it. I think I know why it's doing it. It's getting the buffer block thing for a certain reason. Forget why. Hey Item, Hunter, Gummy, how's it going? So let me quickly check the compiler. In the spivvy file, we give it a block. What gets given a block? If his buffer what is this? If it's a resource descriptor, give it block. Oh, needs block. What needs block? Push constant. Right, storage buffer. Output. Yeah, I wonder why this gets given a block type then, the quaternion. Like, where's that being used? I've not got like an array of quaternions anywhere, or a buffer of quaternions. So I don't know why. That's just bizarre. Let's check that spivvy binary. So there you go, decrypt block. Why did you get made? Why did you get made? Why did you get the block decrypt? What was that reason? Why is that there? Push constant quaternion. When was that made into push constant quaternion? So somewhere it is. Wait, I know. It's oh no. It's not because it's an nested structure. So somewhere it gets a push constant. So there's a function which uses a function parameter. But it shouldn't be marked as a push constant there, because that function is a. I don't think that's an entry point. Return. Yeah, this is that function which will. I don't know actually. Yeah, multiply, quaternion. You need programming? That's me too. What sort of stuff you learning? Oh. Why is it getting this? It's not because of the function. If I remove it from here, does it get the decorate? Right, so that compiled the binary at least. It's PBR binary. There's no quaternions in there. None. None. Oh, it doesn't exist. Right? Yeah, no quaternions in there for some reason. But there's a quaternion in the code. Let's put one in the this hardcode one. Let's just hardcode quaternion rotations. Uninitialize it. Ah, shoot. Right, let's take a look at that. Nothing. There's no quaternion type. It would have compiled it out. That's why. Essentially. Okay. It would have scalarized it or something and then just got rid of it. We could put it as a global variable. Gotta make it const as well. Oh, that messed up. We're finding more bugs. Huh. Quaternions. How can I put it in? Okay, so I guess we could... How can I debug this problem? So it's coming through as a push constant for some reason. But it's only when we add it to this. Right. I think I know the bug. So when you build a compound data structure, aka a structure. Oh no, it's doing it. Passing an invalid when you deduplicate the field. Should be fine. Deduplicate SPIRV type storage class needs a block. It needs a block if it's a storage class is push constant. Any of those. Right. Okay. How could it be passed in? Right. We could open it up in the debugger maybe. It's a release build. Maybe. You know, we could point to this from the HCC one, and we can modify the code, and maybe debug it that way. I just wonder how quaternion is getting... It's not used anywhere else. It's used in here as a local, but then it's just compiled out. Let's turn off optimizations. So we turn off optimizations, that will do it. Let's go to the build script. -O. We compile that. Cool. So here, if we take a look for quaternion now, we've got quaternion. And what we find is it hasn't got the decorate for... It hasn't got the decorate for block. It's just got member decorates. There's no decorate for block. So it strangely gets it when it's used inside the push constant as a field, which is strange. Right. It seems like it could be quite easy to fix. So we put that back, we get this issue here, and then we bring this up here. So the difference is we've now got this decorate block, which is the thing that's causing the which is the error, and it's probably in an extra. It's used in a strut here. Sorry, this function call. I wonder what this function type is. Well, yeah, no, that's not an entry point, right? Where's the function? Not function type. Function parameter. Put into less. Yeah, small v quad as we thought it was. I wonder if this becomes an entry point anywhere, which it shouldn't do. No, it doesn't. Right, if we remove this rotation thing for a moment, that line, we can see if that function is causing the... it is. So this function call itself is causing... Compiling this function in is causing it to get the block. Buffer block. The block decorate. Okay. How? Input is pointer. If it's not pointer, become that. Right, so I think there's something funny going on. It's going to get the need block for some reason. This output here. So for some reason, you've got that parameter, then you got it as a sort of variable function. There's no input, if you will. Input, I think, is on... Your storage class input is specifically if you have stuff like rasterizer state that comes between, that gets passed between the vertex shader and pixel shader. So that's not the reason why it's getting it. Storage buffer. It's none of these things. So it must be accidentally getting this or something. How could we debug this easier? So we're nearly there now. We know that it's because it's a function parameter or something. It ends up getting this block. Oh wait, you can get the block later on. There's a way to add block later on. I remember we put that in somewhat recently. If we go to the header file, decorate. You can add a decorate basically. Yeah. So this function is getting called somewhere. I'm gonna add decorate. There's a way to add it in post. Where is it? It might be in Spear VGen. Because I added some entry has block decorate. This is it. Because there's another way to add a block decorate on. Right, okay, this is a problem. If data type is a compound data type and it doesn't have the block decorate, yeah, so I guess it could be set here. But then still, it's got to have these things on it. I don't think it is because of the parameter. Wait. So let's not have it here. Passed in via the push constants. Let's have it passed in via, or let's just have it as a little local. Does that still, that doesn't have the compile error. So let's look at the disassembly again. Okay, so it isn't because it's a function parameter then, like I was thinking. It's probably because, so it must be because it comes through as a push constant. Man, this is confusing. So there's a push constant. Where does it get used as a push constant again? Alright, so let's put that back. So it's used as a push constant here. Right. It could be when we evaluate this expression. Yeah. When we evaluate this expression, I think we just have to evaluate it. Why don't we try dot x dot x. So it's unoptimized, so this will stay in here. Oh, that works. But if you do the function call, doesn't work. Is it because... What about this? Right, that didn't work. I think it's... So if we build it manually, q.x. Okay, narrowing it down now. So if you build this manually, this is going to be fine. So I think it's this expression here. The way it compiles, it just ends up being recognized as a push constant still, for some reason. That's the reason why. Where's the SpearV code, Jim? So when you do the access chain, is that what it's called? Right, access chains. When it comes from a... Anyway, I think you pass in like a push constant storage class. Right, what's this? Oh no. If it's a shader stage, we just say we're using the push constant parameter as a global variable in the yeah. So that's when you compile the single shader. That seems all right. So access chain. Right, I think we can save this one for another time. But I think we've got a workaround, and that's the main thing. Yeah, that's the main thing, is we have a workaround. And we can get back to actually doing lighting. This is super weird. But yeah, so I think it's going to be a little bit more involved, but look at that over the weekend. For some reason, this expression produces incorrect SpearV. Unhappy face. So yeah, let's hit compile. So we should have the rotations in there. That was way more effort than I hoped for. So now we can finally debug these rotations. And hopefully... Right, there we go. We've got some... So these ones are probably okay. The problem is the this one here needs to do nothing. We need a identity quaternion. I don't know how we're going to make one. You know what? Why didn't I just do this instead? of being a silly. Right, there we go. And then we will also want to do a identity quaternion. Right, for some reason I don't look at that. And then we want the inverse version, so it's like this. So that is right, left, up, down, forward, back. So let's try. So that should help us point to the right side of the cube map, or to sample from the right side of the cube map. Yeah, so we've got some identity quaternions in there now. So let's remove the printing information and let's see the texture viewer. Okay, so this cube map, we should have a diffuser radiance map where, again, right, quick recap, because we did some really silly stuff. The radiance cube map is basically caching diffuse a bunch of raycast in one pixel. So here's the pixel we're trying to cache. We have our normal, which points towards that pixel. We then get this sort of like hemisphere, and we shoot a ray and sample the cube map at all these different places around where these normals point at, basically. Sample, 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 sample. Then we average it all and then poke it into that pixel. And so next time when we're doing some, when we're trying to shade something, we can get the diffuser radiance by simply sampling one pixel. So it's just a caching technique. That's all it is. No, it's just a texture. So the cache is a cube map. There's another cube map. So we're caching it in a pixel. We're shooting all those rays out on the hemisphere, which is half a sphere, right? And we're storing it in the direction in which we're pointing at. The normal is pointing at. So next time you try and render one of these spheres, and you try and render that pixel there, you get the surface normal, which points up, and then you just look at that pixel in the irradiance map, and that's all of the raycast that's shot across the whole cube map, averaged. Yeah, pretty clever. Yeah, we should have it all in there now. Have a look. So the thing we've got the debug mode on, so this is not the proper radiance map, we're just making sure that the directions are all okay. And the answer is probably no. They're getting close, some of them. You need to rotate 108 degrees. That one, right, okay, so 0, 1, 0. Is this a down, the environment map, okay, is this a downsampled version of that? Yes, you can tell there's the building, right? The way we can also tell is if we move it down to a lower MIP, because we've got that at the moment. We'll probably get rid of it. Is that like that? Yes. Next one. Is this one like this? Yes, that other face of the cube map is like that. That's cool. Let's keep going until we've done all 6 faces. Then what we can do is remove the debugging code. So this one is wrong. This one is rotating the wrong way. So that one needs to be negative 1, negative 9. Ooh, crying out loud. I think you understood. Awesome. Yeah, it takes a while for me to understand this stuff too. Don't worry about it. Lots of thinking from me. So those two are wrong. Then what's also wrong is that the 5 doesn't flip. 4 and 5. So the reason why 5 doesn't flip is because we actually need to rotate 180. Right. So this will work. So if we take a look at all of them now, let's go through the irradiance map. This isn't correct at the moment. We've still got this is just debugging. We're just seeing downsampled versions. Oh, 2 went up to the sky. 2 supposed to go to the sky. Oh yeah, 2 supposed to go to the sky. 3 to the ground. Yep. 3 to the ground. Yes. Like Minecraft. 4 to the sea. Or the river, whatever it is. 5 to the trees. Oh. 5's upside down. I took the Y, rotated, and it went. Oh, that was on the X. I'm gonna do that on the Y. Alright, nearly there now. And then we can plug it into the shader and get better diffuse. And then we can do the specular one, which is going to be a bit easier. So that'll be reflections, specular radiance map. Right. So that's 5. Yeah, 5 is good now. Good. So if we disable the debugging code, so this is the one that renders the irradiance map, each face. It shoots a bunch of rays over the hemisphere, averages them, and then stores it in the texture. This debugging code was just sampling from the normal and rendering a downsampled version, basically. But now we've got a proper... Okay, so this is what it looks like now. It's just a lot different. It's just diffuse irradiance. So it's going to look a bit strange. That's cool. The next one... Should we work on the next texture now? Yeah, paintings in Minecraft. Yeah, that's it. So should we work on plugging this into the shader, or should we work on the specular one? Because yeah, maybe we can plug this in. So in the wait, do we use the for now? No, good. Yeah, so they sample the irradiance map. Multiply it by the albedo. And then that's diffused, KD times diffused. We don't have AO, that's ambient. So does that replace the Lambert model? Because Lambert just divides by pi. Taking a closer look at the diffuse integral, we find the diffuse Lambert term is a constant term, the color C, there, and the refraction ratio KD, right, and pi constant over the integral, and not dependent on any of the integral variables. Given this, we can move our constant out of the diffuse integral. This gives us an integral that only depends on Wi, assuming P is at the center of the environment map. With this knowledge, we can calculate pre-compute a new key map that stores each direction. Right, so the thing I'm confused about is their code doesn't have that. Let's go to our PBR now. BRDF. So our diffuse is calculated just using KD multiplied by Lambert, and that is albedo divided by pi. I don't see no divide by pi anymore. Just divide by 3.14, right? So when we sample from our diffuse, I wonder why the divide by pi is there. When we sample by the diffuse, is it just a rough guess? Because the diffuse is just, yeah, I think this replaces this Lambert thing. It must do, because this is diffuse light. Yeah. So I think it's basically a we've now done a better estimate basically by shooting rays, whereas this one is like a very cheap estimate which just doesn't hard code away, I think. Y pi, exactly. Albedo is divided by pi, which ensures that the surface doesn't reflect more light than it receives. Okay. You divide by pi because the BRDF works on infinitesimally small solid angles. Is derived from. The total radiance contribution is summed up. Yeah, so I think interesting. So there's no pi in here anymore. Oh, there is pi. What's that pi doing there? Oh, we've already done the multiplied by pi here. Right. Okay. But then you're not dividing by it anymore. Oh. Can't find that pi multiplication in the sphere convolution. Should it be a division by pi to normalize the term? Links to this thingy. Then the person who writes the article says, I've multiplied by pi. So I believe the multiplication by pi is due to the division of pi in the Lambert diffuse term. KD times WD, right, divided by pi, right. By multiplying the irradiance by pi, we're effectively removing the divide by pi. That's what I was thinking, but is that the wrong way around? Saving us the extra dividing the fragment shader, right? Yeah. That's cool. So the multiplication of pi in the pre-computed multiplied by, but it's multiplied by pi. Yeah, but should it be a division by pi in the pre-computed state rather than a multiplication? No. See this tutorial. The answer is in the shader code. Huh? That's interesting. Because it's multiplied by pi here. Oh, pi multiplied by the inverse of that. Right, okay. Right, I see it. That's cool. So yeah, that pi we need to remove. We need the irradiance map now to be passed in. Let's go and do that. Lambert. Now we know. So I don't know if we need the yeah, we'll bring in the environment map still. We've probably got to see irradiance map. So this is purely for diffuse. But I think we want to do another one in a bit too. So do a sample cube. This is our diffuse or irradiance, I guess. So bring that out from the irradiance map. The direction is the normal, is that right? Surface normal? I think that's right. Let's go up here. I'm glad there's people who are more vocal in comments, so I can come back and I can come here in the future and get answers to my questions. That's really nice. Yeah, it is surface normal. Wait. Direction. Yeah, why are they putting the normal in the dot normal? Shouldn't that be the half? Yeah, it's definitely the surface normal, I think. Oh, no. So, you got your sphere, camera, got your light. Towards your lights. Yeah, would you... Huh. Um... Yeah, I wonder... Yeah, I'm not sure what normal we put in there, to be honest. I'm just going to use the surface normal for now. But I guess we'll wait until we do multiple lights. Because this might have to be refactored a bit. But yeah, so there's the irradiance. Then it's multiply, albedo, irradiance. So we need to pass in the irradiance map as well. Yeah, the environment map might be replaced when we've done the other one. Radiance map. Okay, so we need that to be passed in from the CPU side. So we just need to fill that in when we launch the shader. Here. The irradiance map. And we need the synchronization code as well. Sweet. So let's launch this now. And let's see how it looks. Right, things do look a bit different. I guess what we kind of want is a way to toggle between the old and new behavior. What's an easy way? I can always just pass in a boolean. I guess we could just do a little checkbox. Bit of text. Address of A. Call it checkbox for some reason. String. We're passing in. Okay. Show irradiance. Show irradiance. And then UI box style. We also do have the screenshot viewer, but that's another way of doing it. But this way we can get different angles. And then we can also do it for the specular one as well. I guess that one will be. So defaults to true. I need to put this in the. I need to put this in the globals. So this is all the data that's uploaded from the CPU. So we'll just put that in there as well. So now it's accessible from any shader. Well, it will be in a second. Now it is. Oh, shoot. So what we can do is when we sample that irradiance map and get irradiance, instead we can revive. We can revive the old version. So we say if gfx global show irradiance divide with a scalar parameter by pi. So that's the old one. Here's the new one. So we should be able to toggle and see the difference now. Alright, so here's the spheres. So give it a go. Right, I don't see too much of a difference, not gonna lie. Probably because of the reflection that's going on. What's that diffuse about? Yeah, I actually don't see too much of a difference doing all of that. But I guess it really just depends on the scene, I imagine. Yeah, times by KD, we've done that. Yeah. So we're not really seeing much of a difference. Let's play about the materials a bit. We could also double check actually for a quick second. Is the toggle actually working? So I'm not seeing any difference here. This should be black. Huh? Black, white. Right. That's not, what's weird's going on? Show radiance equal true. We store it in there. It seems to only be changing like when you boot it up. Why is that? Things. The 0 is use as specular. But when I do this, it flickers like crazy. So when I see the diffuse, it's flickering. What? Lambert gets initialized. Either 0 or 1 based on that, then multiplied. For crying out loud, what is that doing there? That MIP level should be 0.1. 0.0, sorry. Yeah, there's no MIPS there. That would have been causing the problem though. I am confused. Let's just put Lambert there instead. Oh shoot, it's a Boolean type, damn it. My Booleans are different sizes, that's why. Right, let's put that back. My Booleans are different sizes on GPU. Forgot about that. Right, so it's got black in there now. There you go. So we're seeing clear change. So now let's bring back the old version. And now we should be able to see a clear difference when we toggle. Okay, so this is the new one with the irradiance map. There's the old one. So it actually brings more brightness to it, which is interesting. But yeah. So it really sort of gets some of the brightness from the scene now. I guess it is quite bright sky, right? So that's cool. Change the intensity, gets obviously bright quicker. Well, that's a different light, to be honest. So let's bring the light intensity down, and you see it's a clear change there. Metalness, maybe you don't see any difference because there's no diffuse. Yeah, there's no diffuse. Diffuse doesn't contribute to the color. The metals does for plastics, whereas the specular is where the color comes from for metals. So we need to work on the hey, Orlin. Yeah, tray racing. Yeah, we're doing ray tracing. We're just ray tracing spheres at the moment. We're gonna change stuff up a bit, but we're just working on PBR right now, making it so that these spheres at least look good. And we have a correct PBR shader, if you will, that we can tweak in the future and extend and probably do like yeah, I think the specular one isn't great, and we need to improve that. So that's what we're going to work on next. So we've done the irradiance map, so that's for diffuse. So it just caches a bunch of rays in the irradiance map for each pixel. We do a normal from there, a normal to produce a hemisphere, which is half a sphere. Shoot a ray and sample the cube map. This is the irradiance map we're visualizing, but the cube map is a higher resolution version. So this is 32 by 32 by 32, but the cube map is like 2K. And then we sample. Wait, was that 32 by 30? I mean 32 squared as a cube map. Then we sample the cube map, average the color across all the rays, and then poke that result in there for the irradiance map. So next time when we've got a sphere in the scene, where's a good example? When we've got a sphere in the scene, we just assume it's in the center of the infinitely big cube map, and we fire a ray based on the surface normal that we're trying to render, and then we'll sample that, and that'll be the equivalent of gathering all the rays from around the scene, basically. So it's just a way of caching that information. So if you do like a GI implementation, you're basically doing that at a more of a micro level for diffuse, at least. So we're going to do the specular one now. So the specular one, from what I understand, is basically a smaller version of that hemisphere. So you're doing it like that's diffuse light, diffuse irradiance, which means it comes from all directions. Whereas specular irradiance, I think you still use the word irradiance. That comes from a cone, basically, and the rougher it is, the bigger the cone is. So we basically need to just produce a version. So what they do here is they pre-filter the environment map. That's what we have done, but I haven't got but I want to. So I think Yeah, let's take a quick read through this, but I think we want to do it in a similar fashion to the way we've done the hemisphere one. So we get the blurring will be nice, and it won't be like a box blur. Um, Wait 2 seconds. I'm just gonna get my water refilled. BRB. Welcome back, everybody. So, specular irradiance, if you even call it that. I don't think you call it that. In the previous chapter, we set up PBR in combination with image-based lighting by pre-computing an irradiance map as the lighting's indirect diffuse portion. In this chapter, we'll focus on the specular part of the reflectance equation. Right, so the first part, when we convoluted, is part of the pre-filled environment map, which is similar to the irradiance map, a pre-computed environment convolution map, but this time taking roughness into account. For increasing roughness levels, the environment map is convoluted with more scattered sample vectors, creating blurrier reflections. For each roughness level we convolute, we store the sequentially blurrier results in a pre-filtered map levels. For instance, pre-filled environment map storing in 5 different roughness levels, right, as follows. Okay, cool. Right. So this is what we did already, but we just did a downsample. And so we've already got the reflect color, and we've already got a very similar looking system here. I've had to do a couple of square roots for it to feel nice. But I'm hoping to be able to remove those square roots with this new system. So we're getting reflections, but I don't think it's as good as it can be if we do something similar to what we've done with the diffuse one. Ooh, convolution. Reminds me of signals and systems. Interesting. Well, what sort of what is that? What sort of programming domain is that from? We generate sample vectors and scattering their amount using the normal distribution function of the Cook-Torrance BDRF that takes as input both a normal and view direction. Yes, that's that Yeah, of course, it's called the GGX Trowbridge rights one, right? As we don't know beforehand the view direction when convoluting the environment map, Epic Games it makes a further approximation by assuming the view direction and thus the specular direction to be equal to the output sample direction. As this translates into the following code. Wait. Output sample direction. Reflection. Well, this way the pre-fill compilation does need to be aware of the view direction. This does mean we don't get nice grazing specular reflections when looking at the specular reflections from the angle as seen in the image below. Right, it's not so bad, but huh. Um, yeah, then they cache the BRDF into a lookup table, which is something we should do in the future for optimization purposes, I imagine. It's from electrical engineering. Ah, fair play. That's something I don't know too much about. But it sounds interesting though. There's so many interesting things that exist. Um, right, so they're just yeah, roughness and producing. Right, pre-filtering a HDR environment map. Ours is not HDR, by the way, because I ain't bothered doing. Right, interesting. So, as we expect, right, the rougher it gets, this just gets bigger. Um, the general shape is known as the specular lobe. As roughness increases, it gets bigger, right? And you need to shoot more rays as well. Um, when it comes to the micro, uh, it makes sense to generate sample vectors in similar fashion as most will be wasted. This is known as importance sampling. Yeah, we haven't really done importance sampling yet. I don't know if I want to do it. I might just do a basic. I might just do a GGX importance sample, number of samples. Uh, interesting. Um, right. Importance sample GGX, roughness, from spherical coordinates to Cartesian coordinates from tangent space. Where's the where's the XI? Oh, that's where XI is. Okay. So this is going to compute that. Um, that pre-filtered color, or the pre-filtered map, whatever it's called. Right, we could just do this. Doesn't seem, you know. I wonder. So the important sampling is being done by this thing, but it's not really like, I don't know how it's gauging what is important. That's kind of interesting. A low discrepancy sequence. In this chapter, we'll pre-compute a speculative portion of the indirect reflectance equation using the importance sampling given a random low discrepancy sequence based on the quasi-Monte Carlo method. The sequence will be used and is known as the Hammersley sequence, as carefully described by this guy. The Hammersley sequence is based on this guy's sequence, which mirrors a decimal binary representation. Okay. So you pass in like a sample index and a surface normal. But then I guess, and he gives you some vector 2 back. Oh, sorry, it's not normal, it's just a UN. Right, so how many of the samples have I gone through from 0 to 1? And then this sort of thing. And this vector 2 is not really a direction. Right. I don't know why you just can't fire off a bunch of... It might be best to visualize it, really, if anything. Because how are you gauging what is important? Why don't you just evenly spread it? Like you're just using a... I guess these pictures are... Right, so maybe... Should have just read some of this. The Monte Carlo integration is effectively... Sorry, is an extensive mathematical topic. I won't dive into much further into the specifics, but we'll mention that there are multiple ways of generating the random samples. By default, each sample is completely pseudo-random as we're used to. Sorry, as we're used to. But by utilizing certain properties of semi-random sequences, we can generate sample vectors that are still random, but have interesting properties. For instance, we can do Monte Carlo integration on something called low discrepancy sequences, which still generate random samples, but each samples are not evenly distributed. Sorry, each sample is more evenly distributed. Image courtesy of James Hild, I guess. So I guess, yeah, I still don't understand. Like, you can just do a couple of for loops and get them to be evenly distributed. When using low discrepancy sequencing for generating non-Monte Carlo sample vectors, the process is known as the quasi-Monte Carlo integration. The quasi-Monte Carlo methods are faster rate of convergence, which makes them interesting for performance-heavy applications. In essence, important sampling is about generating sample vectors in some region constrained by roughness orientation around the microface's half-wave vector by combining quasi-Monte sampling with low discrepancy sequence and biasing, and sample vectors using importance sampling. We can get high rate of convergence because we reach the solution faster. and we'll need significantly fewer samples to reach. Right. Okay. So I guess it's just a better way of producing your samples rather than in a uniform way, if you will. I guess we could just put this in. Okay. It shouldn't be too hard. Let's give it a go. So, what are we producing in the end? What texture did they make again? 128 this time. It's a little bit bigger. Wait. Generate bitmap. Is this in a full MIP chain? Yeah, I think the environment map is smaller. So let's go ahead and get things produced. I don't know what to call it, to be honest. They call it pre-filter map. I guess we can just go with that name for now. But basically what we want is to replace I guess I use the environment map dims as well. Pre-filter map dim. Right. So let's just create those textures. The MIP map, sorry, the environment map used to have MIP maps, but now it doesn't because we was using that. We essentially had it be the pre-filter map. But yeah, it's not going to look as good as this one is going to look. What else do we need to change? Yeah, so the environment map doesn't have MIP maps anymore. Pre-filter map. And then we've generated a range of resource IDs for each texture view, which represents a slice of the cube map for the pre-filter map. So we've got this one, which is a cube map for all 6 slices, right? All 6 layers. Then we just go over and make a 2D array texture view for every single side of the cube map, every face of the cube map. So now we can, where it says render irradiance map, we're going to do that again. But for the generate the pre-filter map. So there's a destination array layer to write into, and we sample from the environment map. And so let's go and figure out how we're going to do this. So apparently there's a bunch of little functions that we need. Here's one. So just dump these in here. So Hammersley radical inverse BDC, whatever that means. So we produce a return a float back. Cool. And this returns a float 32 times 2. So that would be something like that. Cool, so we can use those two functions. This is if you don't have bitwise operator support, you have to do it this way. So we can just skip all that. Now we need a for loop to go over all the samples. Wait. We need this function. Import sample ggx. So let's put this one in here and convert that. This takes the xi one in. Okay, so based on how rough it is, it makes that alpha variable that we see in the PBR code. And it seems like, yeah, based on how rough it's getting, it's producing I guess a wider and wider. So we try and draw it out. You'll have let's just pretend you're shooting a ray down here. It reflects off there. And this is the normal that we're trying to compute for. Well, the rougher it is, so if it isn't that rough, you just need one, basically. If it's a perfect mirror. But the rougher it gets, you actually start needing more, and the cone will get bigger, right? So the reflection will get blurrier. So that's what this is basically doing here. It's producing a wider and wider area. I'm curious though. Right, so which things are not going to compile? Just got to convert them over quick. C code. We don't have double support, so got to put F's everywhere. Sweet. Norm. That should compile. So yeah. So now we just need that for loop that they were talking about. So the bit that was a bit confusing for me, they were like, you're doing less samples, but if you just evenly distributed it based on, like, did a similar for loop to that hemisphere thing I was doing, like, this sample count would just be less, maybe. I don't know. I can always try another version and just compare it to this one. Thankfully this wasn't so bad. So we still need that normal. Yeah, I wonder if we could... You know what, let's comment out some of this stuff. And let's like... I'm interested. In I'm interested in trying to do another version like this one, just comparing it. So anyway, we'll stick with this one. Float 32 times 2 times 3 times 3. Normalize. Crying out loud, vector maths. Yeah, we did do vector maths there. Right, so the problem is they put their V, H and all that the same. Oh no. Normal, reflect, view. The reflect is the same. Screw it, let's do it anyway. Yeah, so let's produce V normal and R normal. So the dot between those two produces a scalar value actually. This is a subtraction between those two vectors. And then this needs to be multiplied by a scalar, which is this scalar here. Cool. When you do a dot product, and do a max so it doesn't go below 0. Right, I think we're pretty close actually. Pre-fill color. What? So where's the other one? There's this one here in it. Drag color. Yes, it's pre-filter color. Just a flat out divide. By the weight? Oh, there's a weight? Interesting. Then I just hard-coded alpha. I'll store that in there. Not a radiance map anymore, it's pre-filled map. Okay. I think we're kind of there now. Hey Master Agent, how's it going? How's it going? So the up and right, we didn't use these in the end. That's cool. Yeah, so I wonder how it compared if we got this version up and running, basically. We'll do that in a bit. So we need to get the color. We need to accumulate the color as well. So I need sample from the environment map, get the color, turn into linear, pre-filter color, accumulate that. But we're not multiplying it by any weights. Then we, yeah, but then we're accumulating the weight here. Okay. So I think that's it. Does it compile? Oh no. Shoot. I've not got that literal in my compiler. Um, which is not bad because it's just taken away 10. Wait. Yeah, so that literal is basically 0 point something like that. I think. I wonder if I did it too many times or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's one more. Because I included that. Um, uh, sure. What did we do? Oh, shoot. Oh, there's a bunch of vector maps going on here. Oh yeah, we did this one earlier, wasn't it? Shuffle these around. Um, wait, tangent up. Oh, okay. So scale it by a scalar basically, and then accumulate the result. Eh. Okay. Cool. Mosley, lowercase. Change that one, did I? N, normal. Why not just do all this stuff in shaded toy like thing? Why we have to build this from scratch? Well, so if I did this in shaded toy, what do you mean? How didn't shaded toy help me build an executable with a game? Like, how? Right, where's the roughness? So for each MIP, roughness comes in. How would you do rough? You'd obviously scale roughness, right, based on the MIP level, isn't it? We, right. Yeah, I'm building some kind of desktop app. I don't know. It's, huh? Like Shader Toy is a viewing platform for GLSL shaders, and they basically end up just being a bunch of ray marching or ray tracing things. It's not going to be a game. You're not going to write a game in there. I guess someone has written a game in there, but you're not going to write like a proper game you sell to people in Shader Toy. Yeah, there's some great examples in Shader Toy. And when you're gonna monkey around with some of the examples just to learn how they work, it's a good place to do that. But yeah, or if you want to write your own little example, and share it with people. Started tinkering on my Teensy 4.1 project yesterday, going back to about 1 to 2 hours a day now is the plan. Almost got the red-black trees working, but it seems I'm running into some stack corruption. No, but not having any means of actually debugging it except my blinking LEDs is slowing things down. No. Interesting. Yeah, I remember trying to do red-black trees before. I don't think I succeeded at it. I think there was a bug, and then I just ended up like I just never went back to the project because I got distracted on something else. Back in those days when I used to do that a whole load. Radio. But yeah, is there another way you can improve the debugging experience there? Oh, here it is. Downsample cube map. We can replace that boy. Yeah, it's a data structure. It's what's known as it's a way to balance your tree. So the trees, you don't have, it's a binary tree, but it's a way of making it balanced. So you have an even number. So basically, you don't just have all of your nodes going down the right-hand side, right? They're evenly spaced along the left and right going down the tree. And that's what balanced tree is. How's it useful in graphics programming? I don't think it is useful in graphics programming. Someone might have found a reason why. But balanced trees have their reasons. They allow you to search quicker down the tree. There might be some use case for it. I'm just not thinking about it. Alright, so we've got a bunch of MIPS. We need to go full ham on it. Render pre-filter map. Radio. So plan is to do another one of these boys and girls. So that'll be the pre-filter map dim. Pre-filter map MIPS count. So you're going over all the MIPS. Irradiance. I need that division. Dim is equal to divide by 2 of that. It's done as well. I need to manually set the roughness. Roughness equal probably MIP. Like, basically, how close is this MIP as flow point? How close is it to just between 0 and 1? Now, if you think about it, you're never going to get 1. And you're never going to get... So you need to do that. You need to take 1 from it. Because otherwise, like, MIP is just an index. Oh, wait. Ooh. Shoot. Oh, but... yeah. There you go. Yeah. So actually, you need to do that division there. that alone. I think that's right. We need to come back to it actually. What the what? Oh, sample vec. Yeah, where is your sample vec? Oh, L. Eh. Add pre-filtered color. Or is pre-filtered color not a... yeah. Nearly there. Wait, what is the radiance map complaining about now? Oh, there's no number of MIPS. No, we corrected that. Okay, I must have undone the code. That's 0. MIP level 0. This one, however, will fail. It needs to use the new row. It needs to replace this with the pre-filter map. And it means we need to pass the pre-filter map in from the constants. Oh, but yeah, we want the environment map to come in if we miss sample from the environment map. Okay. Yeah. So we need the pre-filter map. Right, so here is pre-filter map MIPS. And I don't think we need to do all this square rootiness. Because that should have been done in the that should have been done in the shader when we pre-compute the map. Pre-filter map. Right. Right, that's a double. I don't know if that's actually going to produce anything. Right, so back in here, we don't want to use this downsample cube map anymore. Jettison that. So yeah, we just got to be careful when we launch that tile ray tracer. We need to make sure we put in the pre-filter map. If not, GPU is going to crash, set on fire, and yeah, it's not going to be good. Cool. I think that's everything we need. So we can actually give that a go. I'm writing a bare metal CNET project for the Tennessee 4.1. Wanted some container types to play around with. Compiling with no standard libraries wastes too much space. Need to roll what I need myself. Awesome. Yeah, it sounds like a cool project. Right, if the stream dies, I'll be right back, but it shouldn't die. It should be perfect. I don't know. Wait, what am I looking for? Pre-filter map. I wanted to just double check. Yeah, I think that's fine. Right, here we go. I'm scared. We're alive! Right, so the reflections have now gone. Because we're not using the environment map anymore. We're trying to replace it with our new one, but obviously our new one is wrong. So, pre-filtered map. Ooh. So the layers are all different at least. Yeah, so we want to do some debugging quick. Let's look at that pre-filtered map. So the pre-fill map does do a store. Let's enable this debug thing, and it should. It should just store it should just look at the environment map and just put the pixel from the environment map in the same location. So we should just be seeing the environment map in there. So we are seeing some kind of reflection now, but obviously not as good as what we had before. Right, that looks funky. RGBAU norm. What? Yeah, polluted earth. Yeah, we got our own little immediate mode UI, but you're not using DRM GUI. Yeah, that's correct. Yeah, performance is going to be worse. We've launched another shape. Oh, you mean in the... Yeah, down there. Maybe. Yeah, sampling from two different textures. But yeah, we got our own little custom immediate mode UI. We improved the theming recently, so it looks a lot better. We've got a little texture viewer that's built in, so we can view screenshots and compare screenshots. This is what it used to look like before, so big step up. But yeah, this is when we have reflections. And we had, this was in linear space and not sRGB. Sorry, I didn't convert it from sRGB to linear, so it just looks weird. To improve that. Yeah, we can just view textures, which is cool, in game. And go back in time as well, in the frame. And view when a certain shader wrote to that texture. That's not our font. I need to delete that one. Hey, where's the glyph cache? Ah, there we go. Yeah, there's our glyphs. Woo. Yeah, it's pretty handy. We can take screenshots and compare as well. Why is the color all wrong? The format looked fine. So I'm just storing a debug. Could it be... Okay, the irradiance map uses 32 whatevers. So I think we're storing... Wait, I don't know what the problem is. Oh. Yeah. We're storing it as a different format. So there's only... Okay. Yeah, right. Yeah, so we're kind of using like the biggest texture format, but it's just... We're just trying to make stuff look good for now. Right, so this is clearly wrong. Still. That's weird. Pre-filter map. Oh, pre-filtered map is... This is like the environment map, right? So it's just copied it, which is great. So why then? Oh, is it the MIP levels? What about the MIPS? Okay. different MIP levels have failed. Right, that is because we did a takeaway. There's a DST dim. BC DST dims.y. We flipped the coordinate upside down, so it went out of bounds, which could have crashed the GPU actually. But thankfully that didn't. Right, so that's looking better. It's still a bit messed, I think. Pre-filter map. Something's up there. Right, so we're launching over this pre-filter map. What the hell is going on? DST dims equal to pre-filter map dim. Then we divide by 2 every time. Then we reset it. So 0 would launch over the full thing. Right, the destination texture is not changing in any way. We need to do the base plus MIP. That one. So it was not run into the right texture view which targets a particular MIP level, which we preset those up. Okay, so now the reflections are back in the spheres. You can see them. So we're getting the full MIP level. I wonder how the blurriness works. Oh no, it won't work. Right, okay, so it... Oh. That's interesting. So we got a MIP 1. Ah. Why are we getting... So when you go at different MIPs... Shoot. Wait, how did we do this before we deleted it? Yeah, base plus MIP. That looked legit. So this is if we're sampling from the wrong direction or something? So we go to array layer 1. Let's see what this one looks like at MIP 1. Oh. No, it's just cropping it. Right? Yeah, it's just cropping it. Okay. So this is just, we're just debugging. It's probably because our debug code. You say given a normal Right. The dims is wrong. Yeah, yeah. There you go. The dims was hard coded, so it didn't account for the map levels. So that should, let's test that out. Then we can try enabling the actual code and see how the important sampling thing works, right? So we up the metalness so we can actually just see it. Increase the roughness. It is getting blurrier. It, I had the square roots in it, so it would improve. So it'd be, because here it takes ages for it to actually blur until you get to the end. It blurs really quickly, and yeah. So we take a look at the pre-filter map. I'm hoping. So I used to have some square roots in it, but I'm hoping we can encode. Right. Yes, it looks a bit different. All that GUI custom made, yeah. So it's all just from scratch. How's the slider work? It's got a somewhat complicated maths. So I have a few things, right? I have a scroll area, which is more complicated. And I also have a list, which has its own scroll bar logic. But there's a few, I don't know if I can really go over it, but like, I kind of forget, I'll have to read the code and just remember. But yeah, there's like the scroll bar, there's something to do with like how much space you actually have. Um, Wait, where's something scrollable? Oh, here. Yeah, there's how much area you actually have, so the bit that goes off the page. There's like how much height here you have where the scroll bar fits, and how big this thing is. And obviously this gets smaller with the more entries that are in, or the bigger the content area is. There's some maths basically, there's some divisions and stuff where you're basically remapping that size to this bigger region size. Something like that. Building a browser. Why would I build a browser? why would I why would I embed myself in that like steaming pile of crap world, I escaped it, right? So why would I go back? Um why are my safe passwords here? Get out. Eh. Um yeah. Nah. No thank you. No, you'd be writing JavaScript. You gotta test your JIT, your VM. Right. You get stupid bugs like this that you gotta fix. Um, so, if we simply disable the debugging, we should get the important sampled one right in there. So, this is interesting. Right. Obviously doesn't work. So I think, right. I think the problem, I imagine, is H. I imagine it's this magic number here that I copied. I think we can do a bits. Yeah, that might do it. Right, definitely change the outcome. For crying out loud. Oh. Right, so what's the thing that we could do to sort of like figure out what is wrong? That's not our up. Um, so you could just feed in. I guess your first thing to do is just make H be normal and just see what happens, right? Um, see how that works. So it doesn't move the normal at all, basically. You're just gonna get, so we just get black here. So this is a good place to start. We should so if you dot the same things together, you'll basically just get one because they go in the same direction. And you're gonna get two. So yeah, 2 multiplied by this subtraction. This would be 0. Normalize 0. So they're going in the same direction. We should probably make them go in an ever so slightly different direction. And then it normalizes it. It's always going to be the same. Maybe say h dot x plus equals 0.01. And I'll put it along the x. Right, so what do we get in that texture? Alright, so we're kind of getting the same interesting sort of color in it. And the MIPs are all like really weird. Oh, that's not good. That needs to be that BC DST destination dimensions of Y. That's not what's causing the issue. That's the other MIPS. So I wonder. So right, the next thing to do is just make N. Or sorry, L be normal, and just see if like this code here produces anything sensible. So n.l are going to point the same way, so she put something in there. Right, so I think we get the map working. There you go. It's a bit darker though. We didn't save it back out as linear. Oh. Wait, what's going on? Oh yeah, we need to view it as a linear one because it's viewing as sRGB in it. There you go, says prior. I should probably make that automatically be linear. But anywho. Right, that's okay. So if we... So I think we should look at how L... Look at the code for L again. Normalize 2 times. Ah, shoot. I did that maths wrong, didn't I? I didn't do bid maths like a Wally. So this scales h, and then you subtract. So it actually scales h. And you're subtracting v. Right, that appears to actually be better. Oh, interesting. So increase the roughness. It's getting rougher. Okay, so things are actually happening now. Yeah, I'm still a bit confused by this. So I think what I would like to do to make it feel more linear is do a couple of square roots here. Oh, where's the roughness? Yeah, square root it twice so it feels more linear. Because that's what we tried in the pixel shader. So when we generate the pre-filter map, we're going to square root it a couple of times so the slider feels more linear going from 0 to 1. Let's try that again. Yeah, so now it's like getting... Right, but it does look a bit blocky though in places. So I'm just going yeah. Let's go to that texture viewer quickly. I want to change the way it's selecting like the viewing mode. So by default it's just color. Well, we actually want is a new one. So for those 16 and 32 ones, these should be color linear. So that's the reason why it's actually kind of looking quite dark. This doesn't do the sRGB conversion. Are you not curious how everything looks with other setup with thousands of balls? Huh? Right. Yeah, I guess we could bring this back sometime, but yeah, I'm not sure if I'm going for that kind of look though, where they're all sort of grid aligned. So I think, yeah, we can always try it though, and do a compare before and after though. When we're finished. Mainly focusing on the details though, of individuals spheres right now. I think when you look far away, we've also got to make this blur better. But yeah, nowadays, it just goes blocky like that. Oh, look at that blockiness. Horrible. Should we be using a... So I was thinking you could just change the hemisphere one. Let's go down the MIPS. There's... Oh shoot. Let's go down the MIPS. Let's go away to the end. Oh no, not that one. So, okay, let's MIP 4, say. Let's compare that to the actual environment map. Oh, it doesn't have MIPS anymore. Right. Interesting. You know, I would like to... Well, actually, 2 seconds. Where's that floating point number I deleted? Here. I want to see if that one is the better one. Because the tutorial had it as a floating point with an E -10, but I didn't have that. I don't have that parsing in my compiler. So I manually did it. So let's see how this makes it look instead. Check out the metalness. Oh. Things look really bright. Is that the first MIP? Or second MIP? Oh boy. That already messes up the future MIPs. Right, divide by. Right, so if I poke that in as hexadecimal. Uh, 1 byte, 2 byte, 3 byte, 4 byte. Huh? One too many zeros, surely. Yeah, it doesn't reflect at all, that's true. Yeah, it should be it should be like diffuse basically, right? It'll just be diffuse. So I don't know why it's not doing that, but I think this is a big part of it. This is wrong. But I wonder if we should just take that hemisphere code and just make it condense. It just feels like a better thing to do, but I don't understand this important sampling thing enough, I think. But that's why I want to get the two together and just compare them. Yeah, so that number is, so it's that number. One too many zeros. I don't know, it's weird. Yeah, it's obviously 4 billion, right? The inverse of 4 billion. It is what inverse of 4 billion, so I can't put that as an int. Wait, no I can. So what is that in? Right, if I punch that, floating point representation or whatever, there's like an online thing. And I think you can just punch in. Right. Sweet. So we can take that. So this is, yeah, divided by, you know, 4 billion or whatever. So bits to yeah. So that is basically divided by that. Right. I'll do it. That should be the thing we're missing. Oh. Okay, so metalness up you go. Maybe maybe it is right. You know what? I square rooted the. Wait, why did I square root it? The square root of. Yeah, no. The square roots then should be removed. Maybe it's making it go up to 1 quicker. Maybe they're not needed anymore. Interesting. Right, that seems to be more realistic actually. Because it's just fading it out right over time, but it's actually doing it at a better rate now. Yeah, that's way better. And then it just gets diffused. Yeah. How many zeros was it again? It was enough. It was 8 zeros, right? It was 4 bytes worth of zeros, and then there was one afterwards. So it's 4 billion. Yeah. It was a UNT 32 max plus one. That's the value. Yeah, it did, didn't it? It only first half. Yeah, I was feeling that too. How can I look at that? So we go up the MIPS. MIP 1 is like that. That blur is way better. I'm loving that blur. Yeah. So so it's squaring it in the shader. It's squaring it in the shader when it does all this stuff. Um. So if I just square it here, because if you square it, it'll go on for longer, basically, right? Um. Right. Metalness. Turn that intensity down. Let's do the halfway. Or maybe we just want to or maybe because that's going to make it ramp up slower. You're not seeing any change. You're not seeing any change at the start. Well, you do a bit. Yeah, then it really happens. Maybe what you want is a multiply by 2 instead of a square. Because maybe. Sorry, divide by 2. Okay. So after we've got this looking good, I need to double check the PBR code and make sure that's kind of reflective in what the tutorial was doing. Right, that looks better. Dividing by 2 is ending up being the cool. Awesome. Thank you, Laurie, for the help. Yeah, this is looking much better. This is diffuser radiance as well. Sweet. So I think that's all good. Yeah. So when they plug it into the PBR shader, I already had mine from before, but I just want to double check. Um, the resolution of the source key map per face. Square it times by 6. 4 times pi. S sample. Right, so the way they were grabbing the MIP level, they were doing some more complex stuff in the shader. I thought they would have wanted to sort out in the cube map instead, but I don't know. I think I'm okay with my solution, to be honest. Yeah, I don't think you want to do that. I don't know. These guys know this more than me, so maybe they're right. So this is pre-calculating the BRDF. We've not done that yet. This is a faster version. But this is specifically for specular. Yeah, I think it's possible. Right, so there's the irradiance, we did that right. So your roughness times by that. Oh, so they're not doing it in the shader. Yeah, then they do the BRDF calculation. Right. So we call it the reflect color. Let's find that. Reflect direction. Reflect color. Convert to. Yeah, we don't need to convert from sRGB to linear anymore. Because it's already in linear space. So that'll make it look better, look brighter actually. Right, so reflect color multiplied by the Fresnel of view surface normal. So F normal view, yep. Put a little bit of roughness in there as well. I don't know why they got roughness. They got a Fresnel roughness. Anyway, look at that in a sec. Multiply by the BRDF thingy. Right, reflect color. Where does that go in the end? Add it to the specular. Right, we don't have a BRDF. We do have a BRDF. So we're adding, but not multiplying. We're adding the specular and the cooked torrents here. But these are floating point, and this one is like full-on colored one. So yeah, maybe we're missing something here, but yeah, that one does kind of look quite nice though. So plastic to metal, I guess. Maybe we should change our balls to like red and just see what they look like. But what was that thing? We tried. Yeah, we removed the sRGB conversion to linear conversion or whatever it was. So yeah, they look brighter now. Like they should. Right, that's definitely improved from what it was. Yeah, it's just nice and blurry, like a nice blur. Right, so what am I? So they've got this sort of like. I don't know, should we make ours red and just see what we can do? Oh, wait. We got sliders. So if we make ours like red, there's plastic, metal. Basically, you can see the, you can see the Fresnel, how it sort of like gives this sort of like brighter edge. And it's looking generally darker. They have more brighter parts. Maybe they have HDR. The things are shown through a bit more. I guess if we had more lights, yeah, they probably have HDR, so they've got more sort of lit things that are showing up. Yeah, I guess the light would show up more intense. In the metals. But we don't have that in the environment map, I think. That's from my understanding, at least. Because we saw it with the what did we see it with? Was it the sky? When we did it incorrectly, it got brighter. I don't know. I think maybe these metals could look a bit better, to be honest. I can't. I think the plastics look fine. Metals just take away. Yeah. Right, so I think this is in a good place now. What's left to do for PBR? I don't think there's much left. What I would like to do is clean up this code, that is for sure. Where is it? Yeah, I would like to clean up all this code, comment it a bit to understand it. And I want to probably do a devlog on this and go over sort of like adding PBR into the engine basically in some way. I don't want to optimize it yet, I'm not fussed about that. I just want to clean the code up a bit, put comments in. Thank you. Yeah, it does look better. Especially, yeah, mainly when you increase the roughness. Although I do want to compare that other version. I don't want to compare. But I think it's just good enough. I might not bother comparing it. We could debug draw all of those important sampled vectors that I don't know anything about. Something we could debug. Because it's probably good to understand what makes it important. So we could say if BC destination layer is equal to 0 and roughness equals 0, then that'd be 1,000 things it's drawing. It's quite a lot. And we probably want to say and if I is less than, let's just do 100 for now. Let's debug draw. Wait, are we doing this once per? Yeah, it just keeps doing it. That's awesome. Draw 3D vector in world space. I would like to go from the wait, I forget these things. Right. origin of 0. I would like to draw out h for me, please. Probably want to scale it by some kind of thing like 5 or whatever. Thickness 0.01. Color of blue, I guess. Z test? No, I want to see it through everything. And then we probably want to debug draw the normal in like a green or something. And we probably want to do it at like 7, so it's a little bit bigger. So here we should be able to debug draw some of the important sampling based on one specific. Yeah, hopefully it didn't do too many. Right, appears to be running fine. See nothing. Is it even running the shader? Yeah. Oh. Right. That's a boot though, isn't it? Okay, it's actually not running it every frame, that's why. So is there a way we could... I thought I was running this every frame. Oh, it's inside. No. I didn't see it. It's not in any specific thing. There is this, but this never gets set to true. Is my volume constructor stuff running? It's not. I guess it's inside that same sort of... Oh, it's in here and it has been built. So it is in there. But yeah, if I bring it out, I've got to neuter it. Alright, so we bring this out, we do have to neuter the... we have to make it so it doesn't launch as many. You know, I guess I can just say, just do one layer, one MIP. And now... Alright, hopefully that's cheap. Well, I could have done the lower level MIP. I could say do MIP 4 to 5. So there's less pixels. Wait, that's gonna do it per pixel? DST chord.x equals 0, DST chord.y equals 0. Oh. I didn't put an and in there. Right, hopefully that runs. Right, way too slow. It's taking like 100 milliseconds. You know, we'll just... I'll debug that another time. Okay, so only launched that at the beginning. Right, anything else that I want to think about? Yeah, I want to try the night mode quickly. So this will be the night texture. To see how it looks. Ooh. Oh yeah, we forgot about like going far away. Actually, it's gonna. Well, yeah, we need to. It's gonna shimmer a bit because yeah, something to do. But if we increase the metalness here, I guess those look more metally. I guess. Eh. Um. Ooh, and that roughness. Oh yeah. Yeah, I'm actually digging that. That's good. Way better than it used to be. This actually like those buildings used to get so blocky. Yeah. Plasticky, metally. Right, so the only issue with it now, from my guess, is the MIP level's not being selected right when you zoom out. So it's going to dance around. It's going to get speck. So here, what you actually want is the rougher surface. Is that right? No, you can't. Damn it. Because you'll see it. I don't know how you solve that problem then. It dancey pixels. How do they solve that one? Because what you basically want is a lower MIP level, but the lower MIP levels have the roughness in there. Oh yeah. But you won't. Yeah, you'll get the blur, but you won't get that spec, that normal distribution function, because that's part of the roughness value itself. Yeah. So the way you want to do that is you basically want to compute a. Should be quite easy. So I guess did they solve that in here with that MIP level thing? Um, no. Teams at high roughness, I haven't seen that. Or maybe. Right, okay. So basically we have to select a higher MIP based on how big the pixels are. What's the way of saying it? How big the So say if you have your screen pixel, and when you sample, I guess it's in a cube map one, so it's sort of like shooting a ray, and grabbing the cube map. But like you want to know, you want to select when you hit a pixel on the cube map, you want to select the MIP level where the pixel is about the same size, at least the same size as this one, I reckon, something like that. I don't know if you're gonna clamp it. Because if it ends up being like the small one, like a super small one, when you move the camera just a little bit, it will hit its buddy next door and it will shimmer like crazy. Whereas if you pick the mid level, the downsampled one, you're going to get an average. It's basically an average of those ones, or a nice average, as we've seen. So basically, you want to compute your own. Usually, you'd use like. Ooh. So if you take the difference between your neighboring pixels. Yeah, but then how would you do it exactly? Because your neighboring pixels might not be sampling the same sphere. You could be getting a discon on one pixel could be going off the edge of the sphere, going into the background and miss. So if you use quad intrinsics, all lanes have to be active. Yeah. Right, that's an interesting problem to solve. And because we're in a compute shader, we don't have DDX DDY. DDX DDY is fragment shader only. Yeah, we need to compute the Maybe we can work out based on the ray distance. Or something, right? You have your array. You have your surface, you have your camera over here. When you fire your array, like you know how big you can know how big the pixel is in world space, if you will, by projecting the pixel that you're drawing through. I guess it will grow bigger actually, so make it really small. But you'll project it so you know how big it actually gets a bit bigger. Terrible drawing, but it gets a bit bigger. So you know how big the pixel is in world space? I don't know, maybe you could use that somehow. You need to find the... Is it in text or space or something? How would you do it? So you need to produce a value from 0 to the number of MIP levels. The size of your texel. Is obviously 1 divided, well, in UV space is 1 divided by 2048, but yeah. I don't know, this is something to think about for next time. But I think it's solvable. I'll have a think about it. Cool, so next time we'll fix this problem, we'll clean up the code, and I think what I want to do is create a devlog next time, going over PBR, everything that we've done, which includes showing off a before and after, and then probably talking about the actual code in some level of detail. Probably can't go into every level of detail, but at least explain what I've built and how the basics of PBR work and image-based lighting, I guess, as well. Yeah, I can do that. And point to some resources. So that'll be on Thursday and maybe Sunday as well, depending. After that, we're doing rewriting the BVH traversal, probably clean up code actually. Restart the renderer, and we'll start a new renderer which will be traversing through a BVH. So we'll build a BVH, which we've already done that in the past. We've got the code, it does exist. So it's just taking that and refactoring it into something new, because there's going to be changes to that old code, that's for sure. TCAP. Right, thank you all for coming, everyone. Yeah, PBR is basically there now. That's exciting. So just going to document what's going on with that next time. Yeah, thank you all for coming. Have a good tomorrow. I'll see you all Thursday, hopefully, if not Sunday. Yeah, much love.